Yeah, hello there. So my name is Peter Podgórski, and I'm a solutions architect at STX Next. So being a solutions architect, that means I'm kind of in the middle between developers and sales and our clients before they're even onboarded sometimes. So I help them make the right decisions to start the projects at STX smoothly and successfully. And today I want to talk to you about burning books. Weird topic, I know, but what I want to talk to you about is what happens when you burn a book. A book contains a number of words, maybe some equations, if it's a physics book, for instance, maybe some code, if it's a programming textbook. And when you burn it, all of that is lost, right? We have no access to it, it's destroyed. But not according to the fundamental laws of physics, because according to the fundamental laws of physics, information is never destroyed. This is known as the minus first law of thermodynamics. And this is actually a minus. This is not a hyphen. It's not a bullet point. It's actually a minus. So that means information is never destroyed. So it's still out there. It's just that it's not accessible to us. We can't really do anything about it. We're not getting our book back. But laws of physics are also time symmetric, which means that at the fundamental level, we can run them forwards or backwards, like Thanos with their time stone in Avengers. If you get this reference, so we could, in principle, get our book back, right, and we can read it. And this is demonstrated by a thought experiment of Laplace's demon. Pierre-Simon Laplace was a mathematician and scholar living between 1749 and 1827, and he devised this kind of thought experiment of a hypothetical being who has the ability to know and understand all the laws of physics to arbitrary precision, and also is able to take a snapshot of the universe at any given point in time, also to arbitrary precision. And then it can plug all the positions and momenta of, for instance, our dust and smoke and heat radiation from our burning book, and run time backwards to actually get our book back, right, in principle. So it can predict the future, and it can also retrodict the past, which is a very useful thing, because when we overwrite state, for instance, we run an update on a database, this is basically like burning books, right? That state that's been there is never destroyed, right? Because information is never destroyed, but it's radiated out into the universe. It's lost in the entropy of the universe. It's not going to be accessible to us, but it would be in principle accessible to a Laplace's demon, which would be very useful when someone came to us and said, I clicked on something and lost all of my work. Or even worse, my account balance should be 10 times bigger, which is a very, very bad situation, right, to be in. But unfortunately, Laplace's demon is not real, and it can't really help you. So what we usually turn to as developers is logs, right? We open our logs in Logstash or in text files, and we try to figure out what chain of unfortunate events led to a particular state that is not desirable for our users or our clients. Unfortunately, logs are a parallel universe. They split away from our system. They are stored somewhere outside in a text file, in Logstash, wherever, and they never again come into contact with our system unless a problem occurs, right? So you don't just sit there looking at logs, and your system definitely doesn't sit there looking at logs when everything's fine, right? We typically look at them when something goes wrong, unless we want to just make sure that we maintain them correctly or something like that. But in principle, they become useful when it's too late. And that's a problem because logs don't always tell the whole story, right? sometimes we are in a situation where we have to say, oh my goodness, we don't log that. And these are the words that that either have been uttered or will be uttered by almost all programmers in the world. And this is a very, very unpleasant situation to be in again. Luckily, there is a solution, and that solution is very old, as you can see from that picture, and that solution is accounting. Because accounting doesn't hold state. Accounting derives state. So basically, when you look at your bank account balance, you look at all of the transactions that have been there, you add them, you sum them, and you get your account balance. And event sourcing is accounting for nerds. I mean, for programmers. And what I want to show you is event sourcing in Python. Obviously, this is a 30-minute presentation. It's going to be very simplistic. It's going to be very simplified. It's going to be basically the level of a simple insert and a simple select, to use the equivalent situations from the typical database world. And if you want to see more, this is the moment you take a screenshot, because all the code is in there. All the code is right in that repository. There's going to be another chance to take a screenshot at that. So let's move on to our event-driven persistence layer, because this is basically what event sourcing is, right? It's an event-driven persistence layer. So we have to start with an event. And our event can look like this. I'm using ups instead of data class for some reason, but it's irrelevant at this point, and I don't want to dwell on that. But we have a base class with a producer ID. This is going to be the ID of the entity or aggregate, if we want to use DDD, as Sebastian is going to teach us in a couple of minutes. And we also have an account created event, which has a deposit, because to create an account in our system, you have to put in a deposit. So how do we handle an event like that? Well, we could do it like this, right? We could have our account, and we could pass this account created event into it as a list or any other kind of iterable sequence. But this is not very idiomatic. This doesn't really look like Python. This doesn't really look like our beloved Python. This is very unnatural and unfamiliar. Instead, what we want to do is this, right? We want to be able to just create our account the way we normally would do it, right? We just want to instantiate the class. We want our business logic to be blissfully oblivious of this situation underneath, right? We don't want to have this to have it knowing that there is an event-driven layer underneath. So the bad news is you can't really get rid of that complexity, because that complexity is essentially the root of what event sourcing is, right? You have to have this kind of event handling at this level. However, you can choose where to hide it, right? And this is very often what we do, right? We never get rid of complexity. We just shuffle it from place to place very often. And this is one way to hide that complexity in a very, very ugly kind of thing. But again, there is a method to this madness, and I'm going to proceed to describe what it is. So retrieving state with SQL and an ORM is very simple, right? We're all familiar with it. We all know how it works. You select a record from a database, you feed the values to a constructor, and you're done, right? This is in principle how it works. With event sourcing and an event store, it's a little bit more tricky. What you have to do is you have to create an empty shell of an entity without creating or emitting any new events, which is crucially important, because you don't want a situation where you have your account created event and then a couple of other events and then another account created event just because you retrieved it from an event store. So the next step is to get all the history of events, preferably as a generator, from the underlying event store for the given ID of our entity or aggregate. And then we want to apply that sequence of events on that empty shell, fold it, starting with the create event and moving forward. Now, there's one really cool thing about this, because we can actually stop at an arbitrary point in time, which means that we can very easily bring our system to a state that, for instance, we believe was the cause of a problem. But at the same time, while we could do that in principle with versioning, there is a limit to versioning, because it doesn't really tell you typically where that state came from, right? You can store that information in there, but it's basically like a log. It only tells you what the state was in the past. It doesn't really tell you where it came from. But events with the different event types, they actually do. They are actually like running your system off your log stream. So we have two cases and two constructors, right? One is the constructor for the domain logic, right? And this is the constructor that is very familiar, that looks like every other constructor is just in it. And then we have our repository level constructor, which is completely separate, right? And it works in a different way. And obviously, they both converge on a single thing, because there are things that have to be created no matter where we originate our entity, right? So this is idiomatic creation of an account, right? So we have our account class. We have we can select. We can run this init from the parent class, and we can also take that event, right? So this event handling and event creation thing is hidden underneath the layer of account and inside the class, right? And then we also have our repository, and this looks very much like the sequence of events or sequence of calls of happenings that I listed before in natural language. So first we create a root. First we create like an empty shell of an entity. Then we grab all of our changes, and then we apply all of those changes onto that root and get the final form of an entity. Now, one important thing is that I have purposefully removed all of the, well, not all, but most of the type annotations here, because I found them to be a little too noisy for slides. But this is one of the cool things about Python, that I can do it and still have something that isn't pseudocode, but actual Python. And basically, we don't have a care in the world, right? Our domain logic is oblivious. It looks just like every other hexagonal or clean architecture. We have a repository pattern. We have our entities. We have some methods on the entities to perform operations on them, which is really cool. So this is the new guy on the block, right? We have this. So let's maybe look inside. What are you hiding? So underneath the surface of this other event handling bit, we have this. So we have kind of three layers, right? And this is deliberately separated because one of those blocks lives in the entity parent class, and the other lives in the actual account class. But I didn't want to have classes here because, again, it would be too noisy. And this is the bits that these are the bits that we are to focus on. So essentially, we have withdraw, and at the withdraw level, we do some kind of validation, right? We make sure that you have enough money, and this is the level we're allowed to do that. And then we get the take. This naming convention could probably use some work, but we create our event, and we take that event. the entity takes that event, applies it using the apply method, and it also adds it to history. So we have withdraw, we have take, we have apply. Maybe we want fries with that. I mean, why so many? Well, it's separation of concerns. So withdraw validates, raises exceptions, calls external services, and all the other stuff. Everything we don't want happening at the repo get level, because we really don't want to call PayPal every time we get something from a repository, right? We really don't want exceptions raised for bad reasons every time we get something from a repository. We don't want notifications sent out every time we get something from the repository. So this is the level or layer where you're allowed to do that. Then you have take, which is like a wrapper. It's basically just to add stuff to history for the new events, right? And handle some event agnostic stuff around it. It's basically just housekeeping. And then we finally have apply, which implements the actual change in response to the particular event. And we use some, well, rather fancy Python, or at least Python which isn't as commonly used as it maybe could be, which is single dispatch. We have one apply, and it's always just apply. And then we have multiple implementations of apply, which are selected based on the event class, which is passed into the original apply. So this is very, very nice way of avoiding the kind of huge dictionary with event class handler, event class handler, event class handler that we could have had if we didn't use single dispatch. So I encourage you to try it out. It's a really, really nice feature in Python. It's obviously also in other languages, but it's not as popular in Python as it probably could be. All right, that's very, very cool. But what about saving? Well, that's easy. And can you have a Python presentation without a reference to Monty Python? I don't know. Maybe you can, but yeah. So we have a repository, and basically all that we do is we get our event store, we call a function on it, a method on it, we pass the account ID, right, or the ID of the entity, and also the uncommitted changes, which are changes that are new since we've created or retrieved this entity from the repository. And that's it? Well, obviously not, right? There's a lot of other things in there. There's versioning. There are situations where you change the version of the entity, and all of the existing events still have to work. There's a case where you update an event, and all old and new events have to still work in the same stream, right? There are situations where you have to add new events, and so you have all of your history and then suddenly a completely new event. But this is obviously beyond the scope of this presentation, which apparently took me a little quicker than I anticipated. Obviously, this is not the end, but I know where I am. So I encourage you to read about this, to learn more about this, because it's a fascinating thing. It's a very nice tool to have in your tool belt. But what about reading, right? So what we did so far was we created an account, we saved it into a repository, we made changes to it, or we created it, we made changes to it, we saved it to a repository, and we retrieved it. But what about reading? Reading looks slow, and that's just one of the problems. But the other is that it's basically impossible to query that, right? How do you find a specific account with, for instance, I don't know, with a specific account balance, right? Or with an account balance larger than X? How do you do that, right? Well, that's where command query responsibility segregation comes in. And this is actually something very, very interesting. This is a term coined, I believe, by Greg Young, who is a very very interesting person and a very skilled developer. And I encourage you to look for his talks and articles on the internet. However, what CQRS is for is basically, or what it's about, is basically separating the reading from writing, like completely, right? So to the extent that your domain models or your entities and your aggregates, they don't even have something like a getter, right? Or any kind of readable, non-private parameters, right? Or attributes. You just don't use that for reading at all, right? You use it just for you use it in the way Alan Kay intended for object-oriented programming. And the left side here is where your domain model lives, and that's where event sourcing lives. And it retrieves states, right? Retrieves the domain domain objects from the event store, right? And it folds all of those events, gets to a state, right? And validates, for instance, certain operations, or performs certain operations, and then stores it back into the event stream. And on the right, you have a read model, right? Which is like a dedicated thing to perform queries and perform searches and things like that. And then underneath you have a read model database, which is fed, or it gets data from the event store. And that could be something like Elasticsearch or AWS Neptune or DynamoDB or Postgres or MariaDB or whatever. And this is actually a very interesting thing, because if you've ever built a system which used, for instance, Django as the main application, and then had a side dish of Elasticsearch for full text search, basically, then you basically should get what CQRS is essentially about, right? Because this is exactly that model, just turned to 11, right? Just made a bit of a little bit more strict and a little bit more formal. So, is event sourcing a silver bullet? And would I suggest you write everything in event sourcing from now on? Obviously not. This is a very, very rare thing to do. And there are many reasons for that. First of all, storing all of those events usually takes a lot of space, right? So it's expensive. And also, as this slide says, you actually get eventual consistency as a free bonus in case of CQRS. So this is obviously another thing to worry about. So no, it's not a silver bullet. It's not a solution to all of your life's problems. But if you have a system which has to be very auditable, which has to be very robust, right, then it's a tool to definitely take into consideration. Maybe not to shortlist, but to consider, right? So it's a very interesting thing, and I encourage you to read more about it. And to read more about it, you have these names, right? I don't believe there's a book on event sourcing, but there are many, many resources, and Greg Young actually has a very, very nice course on or training on event sourcing available. It doesn't have a great production value, to be honest, but it's absolutely tremendous when it comes to merit, when it comes to the information that you get from it. There's also Derek Comartin or Code Opinion on YouTube, who is also very, very good. And you have Event Store, which is the which is a database that is dedicated to being an event store, right? So you can basically technically build an event store out of anything, a document database, an SQL database, maybe not a graph database, but in most cases you can you can use something like Postgres. However, if you want to go all the way in, event store is probably a really good choice to consider, although it's obviously expensive. And there's also an article of Martin Fowler's blog about event sourcing, which is great. And it actually shows you a number of ways in which you can separate concerns between entities and repositories and events, which kind of shows you the different opinions on there and different usages based on the exact needs of your domain. And there are also two examples, right? Here's my example again, and there is also Greg Young's repository for simple CQRS, which I used to learn this. So this is a great resource to read. Obviously, it's not in Python, but I believe it's in C#. But I still encourage you to read it because it's really, really good. And yeah, that's it. That's been my talk.
Right, Piotr, thank you so much. Or should I say Peter? Thank you so much for the presentation. And thank you. It was really interesting to listen to. Now is the time for Q&A. If you've got questions, please just shoot. We had one question that I just wanted to address on the stream. Is the conference recorded? If you're watching this on YouTube, most likely because it's the only place you're streaming. We're streaming right now. If you have the link to the conference, then you also have the link to the recording. It's the same link. This will be still available after the conference is over, but you won't get to ask questions live. You won't get to take part in the contest, which is still coming up, still later. You won't get a chance to get that Nintendo Switch or that gaming chair, etc., etc. So it's well worth watching live. A few words of praise from Jacek. Great presentation. I love when concepts are explained using real-life-ish problems. Yeah.
Real-life-ish is a very nice way of putting it. Yeah.
Yeah, I love it when I have real-life-ish problems. And then, okay, but we do actually have one actual question in the comments waiting right now, although usually they roll in just a few minutes. Just Lavo, sorry if I'm mispronouncing that, is asking, does Python have a good production-ready event store library implementation with pluggable database, I assume, adapters?
Mm-hmm.
If it exists, do you use that at STX Next on prod? What's the answer?
Yeah, this is actually something I struggled with whether I should put it into the presentation or not, because there actually is a library for event sourcing, not just event store, basically just event sourcing, which is basically the first thing you get when you type event sourcing Python into Google. However, I don't encourage you to use it. I encourage you to check it out. I encourage you to read it. I encourage you to maybe even join the Slack channel for it, because it is absolutely a great learning resource, both in how to do things and how not to do things. But it's more of a research project, right? So it's not really something that you should be using in production. That said, basically everyone I listen to in this regard, right? So most notably, obviously, Greg Young, but also Martin Fowler and others, basically encourage you to not use frameworks or libraries for that, because the implementations that you typically come up with are very much domain specific, right? So you don't really you don't really want to do that. And in many cases, there are ways of dealing with things that may not be the best for you or for your storage mechanism of choice. For instance, the aforementioned Python event sourcing library is completely incompatible with Event Store, right? So if you wanted to use that, unfortunately you're out of luck, right? So there is this DIY aspect to it.
I see. Okay, thank you for the answer. Hope that answers the question. Cheslavo, again, I probably butchered it. Samir left a comment. I can't not feature it. He's saying, very nice presentation. Thanks. See, this is the problem when you call the previous presentation the best presentation. I mean, this is nice, but yeah, do keep telling us how you feel about each presentation, Samir. We will feature this on the stream. Anyway, on to more questions. I've got 3 more in the pipeline. Let's get to them. Przemysław is asking, what is your experience related to events versioning? This sounds like a lot of overhead, question mark?
Well, yeah, this is obviously a problem. This is obviously kind of an overhead, but there are ways of dealing with that. I don't know if we have enough time to discuss that. And I don't know if I have enough experience to talk about that, because obviously, I don't have like huge experience with this. However, basically the point is that this is essentially handled in a similar manner that you would handle any kind of backwards compatible change in any database, right? So you have to ensure that that the records that are already there are useful, right? And you can do that either through upgrading the events that come from the event store, or by keeping a handler on the actual entity, right? So yes, it is an overhead, but it's also something you should think about when you use a normal relational database, right? It's not it's not really any different in that respect, although the solutions are slightly different.
All right, there we go. Hope that answers the question. And we have a couple more to go, at least right now. Michał is asking, did you work on any non-primitive Python project using event sourcing?
Depends on what you mean by non-primitive, but yeah, I don't have a lot of production experience with event sourcing in general. I have a lot of experience with building dedicated read models, with the CQRS side of it, but not with event sourcing. And this is actually not all that unusual, because event sourcing is just not all that popular, right? Unfortunately, and I wish it was more popular. That's why I try to encourage people to experiment with it, so it gains more popularity and we can see more of it in the wild, right?
All right.
And as for STX in general, I'm not sure, right? We have a lot of projects, and there's a huge history to the company, and I only know a subset of it.
All right. Well, if there's anybody from STX watching and they want to add to the discussion, the comment section is open. Go ahead and do that. Comment section, live chat. I suppose it's one and the same for a live stream. All right. Related to what we said before, Czeslaw was saying thanks for the answer. Seems like there's still a niche to write such a library then. I guess there is.
Yeah, there could be, but at the same time, again, this is the approach of of people who are a lot smarter than me is basically not to do it, right? So essentially, there's a lot of presentations, especially by Greg Young, which have a slide with huge fonts saying don't build frameworks for event sourcing, right? So, and for CQRS, because again, there are different ways of dealing with that, and we don't really want to limit ourselves to a single solution, which is imposed by a library, right?
Okay, interesting. So that kind of leads me to the next question, which will probably be the last question, and then we'll be switching over to Maximilian, who I can see is already waiting in the wings with his presentation. And the last one that we haven't addressed yet is, when, in your opinion, is it worth using event sourcing then?
Well, I believe when you need really, really good auditability, right? So event sourcing basically came up with basically comes from accounting again, right? So this is basically how your banking system works, right? Underneath, internally. So if you need that, if you need the ability to have absolutely robust auditing, to be able to say, because event sourcing is append only, right? So you never change your events once they're in the stream, right? So you can basically use something that's called a warm drive, right? Which is write once, read many. So whenever you try to change an event, it won't let you, right? So so whenever you are audited in any way, and you can just say, okay, this is our audit trail, and it's never been altered because it's physically impossible, right? And then everyone is like, oh, great, that's really nice, right? We can be sure of this auditing process. And at the same time, the other good reason to add event sourcing to your system is when you need the ability to go backwards and forwards in time, right? So if you have the need to regenerate a report, right, which was generated like many moons ago, then using event sourcing is a great way to do that. And one of the reasons is exactly versioning, because event sourcing imposes backwards compatibility on you, right? Because you have those events, they are unalterable, they're in the stream, you can't change them, right? So so you have to keep your system backwards compatible. So you ensure that the report, if you generate it a year from now, is still going to be exactly the same as it was generated today, right?
That is a fascinating answer. I don't have a technical background. Maybe I didn't get all of it, but it was still fascinating to listen to. So thanks. And I hope it answers the question, Rafa, obviously. Thank you, everybody, for the comments. I'm going to remove the presentation. And wow, we're following the agenda quite precisely. So I think I'm going to, you mentioned Thanos, right? I'm going to snap you now and bring Max into the presentation. So 3, 2, 1. Thank you so much for being here. See you next time.
Thank
it worked. There you go.